Hello friends, here in this video we will see a problem on calculation of moment of inertia for a given lamina. Here we have a question. Find Ix and Iyy of the uniform lamina as shown in figure. The diagram is given. The diameter of the semicircle is 100 mm. So we have to find Ix and Iyy for this lamina. I'll write it in the data. Here Ix is the moment of inertia about x-axis and Iyy is the moment of inertia about y-axis. Now, as this lamina is given, which is also called as a plane figure, the diameter of the semicircle is 100 mm, so radius is 50 mm. Now, if we look into this diagram, it can be divided into one rectangle and another semicircle. So, this rectangle will be area 1 for us, or for the first reference, and semicircle would be the second area. Now we need to find out the moment of inertia for this composite section, and for that the first thing is we should know the location of centroid, because once we have centroid then only we can find moment of inertia. So let us try to get the solution to this problem. Now, in order to find the centroid, first I'll say that since the location of centroid with respect to y-axis is given by x bar is equal to a1 into x1 plus a2 into x2 upon a1 plus a2. Keeping this as the first equation. Next, similarly, the location of centroid with respect to x-axis is given by, it is y bar is equal to a1 into y1 plus a2 into y2 upon a1 plus a2. This will be the second equation. Now we need to find out all the values here. So first we'll get area 1. Therefore A1 will be equal to, the first figure is a rectangle having width 300 and depth 100. So it is 300 into 100, so that is equal to 30 into 10 raised to 3 mm square. Next, x1 is equal to, x1 is the location of y-axis for the first figure, so the y-axis for the first figure will be at half of 300. So this distance of the y-axis for first rectangle, that will be x1, and x1 comes out to be 150. And y1 will be the location of x-axis for the first rectangle, and that will be at half of 100 mm, because 100 is the depth here, So the x-axis for the first rectangle, it is at half of 100, so it is at 50 mm. Next, similarly we'll calculate the other values, that is area 2. This will be equal to, here the radius is 50 mm and we want to find out the area of this semicircle. So it will be pi r square divided by 2. That is area of circle divided by 2, which gives us the area of semicircle. Here the radius is 50 mm. So therefore area 2, it comes out to be 3.93 into 10 raised to 3 mm square. x2 is the location of y-axis for the semicircle, and for this semicircular portion its y-axis will be passing through this center. Y-axis for the semicircle located at 50 mm distance, because this is the radius from y-axis. So therefore x2 is equal to 50 mm. y2 is equal to, now y2 is the location of x-axis for the semicircle. Now if we have a semicircular portion, its x-axis is located at distance 4r upon 3 pi from the rectangle. And now this is the x-axis for the semicircle. We want to find this location of x-axis with respect to the x-axis here. So that will give us the distance y2. So it will be 100 plus 4r upon 3 pi radius is 50. So therefore y2 value, it comes out to be 121.22 mm. Now after we have got these values, we can put them in equation 1 first to get x bar, and then in equation 2 to get y bar. So here I'll say that therefore put all values in equation number 1 and 2 respectively. So therefore the first thing is x bar, that will be, it was a1 into x1 plus a2 into x2. Here we have equation 1, divide by a1 plus a2. So I'll put the values here. So first is a1, it was 30 into 10 raised to 3 into x1 150 plus a2 3.93 into 10 raised to 3 into x2, which is 50, divided by a1 plus a2. So from this I'll get the answer of x bar as 138.42 mm from left hand side, because this was our reference. We were taking the distances x from the y-axis, which was located at left hand side. Next, therefore x bar, I have got the value from left hand side. Now I want the value from right hand side. For that, from total, that is 300, I will be subtracting 138.42. So therefore I'll get x bar as 161.58 mm from RHS, that is right hand side, So now after getting x bar, we can locate it onto the diagram. Here this was the y-axis for the first figure, which is the rectangle, and it was located at a distance of 150 mm from left hand side. Now we have found out the location of y-axis for the complete figure. It is located at 138.42 mm from left hand side. So this distance will be less than 150. So somewhere here this y-axis of the complete system will be there, and it is 138.42 mm. So 138.42 mm from left hand side, and from right hand side it is 161.58 mm. Now this indicates the y-axis for the complete figure, and this was the y-axis for rectangle 1. Here is the y-axis for semicircle second. Now after getting the location of y-axis, next thing is we should know where the x-axis is there, because once y-axis is located, it is clear that centroid will be there on this y-axis, but at which height, that we have to calculate by using y bar. So I'll put the values in equation second here. So in equation second, we were having y bar as a1 y1 plus a2 y2 upon a1 plus a2. So therefore y bar is equal to a1, it was 30 into 10 raised to 3, y1 50 plus a2 3.93 into 10 raised to 3 into y2 121.22 divided by area 1 plus area 2. So therefore y bar comes out to be 58.25 mm from bottom, because we have taken the references from bottom. Next, therefore I even want to calculate the distance from top. So for that, from the total height of the figure, which is 100 plus 50, that is 150, minus 58.25, that gives me 91.75 mm from top. Now after getting the location of y bar, we can locate it onto the figure. Now y bar is 58.25 mm from bottom. So if we see into the diagram, the x-axis for rectangle number 1, this is located at 50 mm from bottom, but the x-axis of the complete system is located at 58.25 mm from bottom. So I'll mark that x-axis just above 50. So here we have the value as 58.25 mm from bottom, and from the top it is 91.75 mm. So here we have the location of x-axis. So once we have the location of y and x-axis, their intersection will give us the centroid. So this is the location of centroid, and after locating this centroid we can get the moment of inertia about the respective axis xx and yy. So now we'll start the mi calculation. Since mi about horizontal centroidal axis is given by Ixx is equal to Ixx1 plus Ixx2 plus Ixx3. This will be equation number 3. Now first we'll calculate Ixx1. So therefore Ixx1 is equal to mi about horizontal centroidal axis for rectangle 1. Therefore Ixx1 is equal to Ig1 plus area 1 into h1 square. This is by parallel axis theorem. Now why we are using parallel axis theorem is because if we look into the diagram here, the x-axis of the complete figure is at 58.25 mm from bottom, but if we look at the x-axis for rectangle 1, it is at 50 mm from bottom. So there is difference between the two axes, and that difference is called as h1. So since there is distance between the two axes, we are calculating the moment of inertia for rectangle 1 about the x-axis of complete system, which is at 58.25 mm. Now if we see here in the diagram, here there is distance between the two axes as h1. If this distance is 0, then there is no need of parallel axis theorem. But since we have some distance, that is why we have to use the parallel axis theorem, and for that I have written the formula. Therefore Ixx1 will be Ig1 is the mi for rectangle number 1 about its own axis, which is at 50 mm distance. So about this horizontal axis, the mi will be bd cube by 12, because it is the formula for a rectangle about the horizontal axis. Area is b into d, and here we have h1 square. So if we go on putting the values b and d for rectangle number 1, b is 300, d is 100. Plus area was 30 into 10 raised to 3. Now h1, it will be 58.25 minus 50. So from this, if we go on calculating, I'll get the answer of Ixx1 as 27.04 into 10 raised to 6 mm raised to 4. So this is the value of Ixx1. In the same manner, we will calculate Ixx2. Ixx2 is equal to mi about horizontal centroidal axis for rectangle, or here the figure is semicircle, So for semicircle,
second.
so therefore Ix2 will also be Ig2 plus area 2 into H2 square. By parallel axis theorem. So here if we see, the x-axis of the semicircle is at distance 4r upon 3 pi from its diameter, but the x-axis of the complete system is at 91.75 mm from top. It means there is distance between the two axes, that is the two x-axis, which I can extend it here. This is the x-axis for the semicircle and here is the x-axis of the complete system. So there is the difference between both of them, and that difference would be called as H2. So again, as there is distance, we have to use parallel axis theorem. So we have written the formula here. Now therefore Ix2, Ig2 is the mi, moment of inertia, for the semicircle about its own x-axis, which is at 4r upon 3 pi distance, and that formula is 0.11 r raised to 4 plus area 2 we have calculated previously, 3.93 into 10 raised to 3. H2 is the distance between the two axes. Here if we see, previously we have calculated this distance as y2, and the answer of y2 was, it was 121.22 mm. That was y2, which we have calculated previously. So here we have y2 value 121.22 mm. And now if we see, then from 91.75 mm, here we have to subtract this small value, which is here, this height we have to subtract, then only we can get H2, because this is 91.75 and as we know that this distance is 4r upon 3 pi. So from the total radius, if I am able to subtract 4r upon 3 pi, that will give me this value, and from 91.75 I will subtract this to get the value of H2. So that is minus r minus 4r upon 3 pi. So here I will go on putting the values. Radius is given as 50. Next, here I will put the value of radius. So if I go on calculating this throughout, I will get the answer of Ix2, which is 16.27 into 10 raised to 6 mm raised to 4. Next, after getting Ix2, we can say that put the values in equation number 3, and since in equation 3 I had written Ix3 also, here Ix3 is not there, so I can write down Ix3 is equal to 0 because we have only two area. So Ix1 plus Ix2. So therefore put Ix1 and Ix2 in equation number 3. So in equation 3 we have Ix is equal to Ix1, that was 27.04 into 10 raised to 6. Ix2 16.27 into 10 raised to 6. So after adding them, I'll get Ix, and my answer is 43.31 into 10 raised to 6 mm raised to 4. So this is the first answer. Moment of inertia about x-axis. Now, since mi about vertical centroidal axis is given by Iyy is equal to Iyy1 plus Iyy2. I'll keep this as equation number 4. Now I need to calculate Iyy1 and Iyy2. So therefore Iyy1 is equal to mi about vertical centroidal axis for rectangle 1. So therefore Iyy1 will be equal to Ig1 plus area 1 into h1 square. This is by parallel axis theorem. Now Iyy1 that will be given by Ig1 is the moment of inertia for rectangle number 1 about its own y-axis, which is located at 150 mm distance. So that will be db cube, because about the vertical axis the formula for the rectangle is db cube by 12 plus area is b into d, and here we have h1 square. Now why we are using parallel axis theorem is that because for the first rectangle its y-axis is at 150 mm distance, but the y-axis for the complete figure it is at 138.42 mm. So there is difference between these two axes, and this distance is called as h1. So it will be 150 minus 138.42. So here if I go on putting the values, d is 100, b is 300 plus area was 30 into 10 raised to 3. Now h1 is 150 minus 138.42 square. So therefore if we go on calculating this, the answer of Iyy1 it comes out to be 229.02 into 10 raised to 6 mm raised to 4. So after getting Iyy1, we'll get Iyy2 is equal to mi about vertical centroidal axis for semicircle second. So therefore Iyy2 will be Ig2 plus area 2 into h2 square. This is again by parallel axis theorem. Now if we see here in the diagram, then the y-axis for semicircle is located at 50 mm distance from the reference axis. Here this is 50 mm, but the y-axis for complete system is located at 138.42 mm from the same axis. It means there is difference between the two y-axes, and that difference is called as h2. So h2 will be 138.42 minus 50. So here I'll put the values. Therefore, as we have written, it is Ig2 plus area 2 into h2 square. Ig2 means the mi for the semicircle about its y-axis, and that is given by pi by 128 into diameter raised to 4. This is the formula of moment of inertia for a semicircle about the y-axis, plus area, it was 3.93 into 10 raised to 3. Next, H2 is clearly visible, it is 138.42 minus 50. So therefore Iyy will be, here if I put the value of the diameter is 100 raised to 4 plus this. So from this I'll get the answer of Iyy2 as 33.18 into 10 raised to 6 mm raised to 4. So once we have got Iyy1 and Iyy2, so therefore put Iyy1 and Iyy2 in equation number 4. So here we have Iyy is equal to Iyy1, it was 229.02 into 10 raised to 6 plus Iyy2 33.18 into 10 raised to 6. Adding them, the answer comes out to be 262.20 into 10 raised to 6 mm raised to 4. So this will be the second answer. That is, we have calculated the moment of inertia about y-axis for the complete system. Now, if we look into the question, there were two things asked, Ix6 and Iyy. Ix6 is the mi for the complete section about its x-axis, that is Ix6. We have found out the value. It is 43.31 into 10 raised to 6 mm raised to 4. Ix6 is done. Next, we had to calculate Iyy, that is the mi for the complete section about its y-axis, and that answer is 262.20 into 10 raised to 6 mm raised to 4. And once we have solved both the questions, we can say that the problem has been completed.